You'll find that this video is really just a continuation of the last, but I'm trying to break them into small parts so that you can get up and take breaks as you need to, because I know this is a lot of information. Um, so I would love to have you here at school so we could do these over 2 or 3 days and work on them together, because I think you all working in groups would be ideal. So we're doing the best that we can while you're at home and I'm here at school by myself. Please do log on to Zoom and ask me 1,000 questions. It would be quite reasonable for you to do so because this is a lot of information to take in. All right, I think that we maybe have even done these exact graphs before, but we're still going to be using the information we learned in the last video, but I do need to make a comparison between net and total change. I think we touched on this a little bit earlier when we were finding definite integrals using geometry formulas. So you know that when I ask you to do problems like this, what you're going to do is say, okay, let me go ahead and label the picture. You don't have to label the picture, but it tends to make it faster. And that triangle is a 2 by 1. If it was a rectangle, the area would be 2. It's a triangle, the area is just half of that. This triangle is a base of 1, 2, 3, 4 and a height of 2. 4 times 2 is 8, so it's half of that's 4. The semicircle has an area of, let's see here, r is 2 squared, so pi 2 squared would be 4 pi. It's only half of that, so it's 2 pi. So we said when you find this integral, you're actually finding net change, which means that you allow the areas under the x-axis to be negative, and then your final answer could be negative if there's more area below than above the x-axis. So in this case, I would say, well, from -6 to -4 is, or from -4, excuse me, to -2 is an area of -1. From -2 to +2 is an area of -2. And then from 2 to 6 is an area of 4. So I'm going to say that that's 3 minus 2 pi, okay, which is negative. 3 minus 6.28 would turn out negative. Now, if I want total change, then I have to do the absolute value of f of x. And remember, the idea is what you're doing is you're actually looking at the reflection of the negative parts above the x-axis. So I would say the area here is still 1, the area here is still 2 pi, and the area here is still 4. But that's when you find the areas, and you want to know the area enclosed without regard to where it's located. So the total amount of area in the first triangle is 1. It doesn't matter that it's below the x-axis or above the x-axis. The area of the semicircle is 2 pi. The area of the second triangle is 4. So your total area is going to be, oh, nope. That was my computer acting nuts. 5 plus 2 pi. So the total area will quite often be more than the net area, because the net area allows for you to subtract values off that are negative. Total area, you add everything. Okay, so how does that apply to what we're doing? Okay, so I'm going to give you a real simple particle motion problem where we're going to think about marching around on the x-axis. But we're not going to do a whole lot of calculus, but just get you in this mindset. So let's see here. Suppose you walk along the x-axis. You move 2 units to the right, 4 units to the left, 9 units to the right, and 1 unit to the left. If you start on the origin, where do you end? Okay, so if I'm at 0 for my starting point, the first thing I do is move 2 units to the right. So I'm going to wind up at 2 on the x-axis. Then I move 4 units to the left. So then I wind up, if I go 4 units to the left, I wind up at -2. Then I move 9 units to the right. So if I go from -2, if I go 9 units to the right, I'm going to wind up at 7 on the x-axis. And then I go 1 unit to the left. 1 unit to the left puts me at 6 on the x-axis. So where do you end? So the answer for part A is 6. Okay, I wind up at 6 on the x-axis. What is your net change in position? Well, again, I started at 0 and I wound up at 6. So my net change in position is 6 units to the right. That was my displacement. I was displaced 6 units to the right of my starting point. What is the total distance you traveled? Now that's different, because now what I have to look at is the total distance I traveled was 2 units to the right, then I traveled 4 units to the left, then I traveled 9 units to the right, then I traveled 1 unit to the left. So I actually traveled, I think, 16 units. Okay, so the difference is that this 6 was starting at 0, moving 2 units to the right, 4 units to the left, 9 units to the right, 1 unit to the left. So that's the difference. Is part B would be net change, part C was total change. So this would be integrating just f of x, so to speak, with my bounds of a and b. This would be integrating the absolute value of f of x. So that's the idea. And let's make sure here. Let's see here. That's 11 minus, yes, 11 minus 5 is 6. I want to make sure that I all my numbers were agreeing. So that's the basic idea when you're thinking about net and total. Now, net change in position is displacement. Okay? And that's just another, trying to connect vocabulary to the last video. All right, so now we're going to do a little bit more complex problem using our same ideas. So a particle zips back and forth along the x-axis. Its position is given by the function x of t. At time 0, the particle is at 4 on the x-axis. Oh, okay. So guys, this is important. At time 0, the particle is at 4 on the x-axis. I would say that its position on the x-axis at time 0 is equal to 4. So instead of writing like an s of t, I'm going to say x of t for position, just to be more specific. So the velocity is given by v of t equals 6 cosine t. So sketch the velocity from 0 to 3 pi over 2. All right, let me do that really quickly. So I've got pi over 2, pi, 3 pi over 2. 6 cosine t is going to put my amp at 6. So my maxes and mins are going to be at 6 and negative 6. I know a cosine wave starts at its max, goes to the axis, goes to the min, and goes back to the axis. Okay? So there's my graph. Now, I know if I find the area under a velocity curve, I'm going to get position. We talked about that, or distance traveled. So let's see. Find the displacement of the particle. So this particular problem, if I want the displacement of the particle from 0 to 3 pi over 2, then I'm integrating technically 6 cosine t as is. All right. Now, let me ask you something. Do you all recognize that this first area and this second area, if I half that, and that third area are all like you're finding almost the area of little, they're not quarter circles, but that's what they remind me of. So what I think I'm going to do is just find the area of one of them and then multiply that. I'm just going to find the area of one of them, and then I'll tell you what I'm going to do. All right. Let me erase that stuff that I just drew in there. So let me say that I'm going to go from 0 to pi over 2, because I think this might help me on something a minute from now. Of 6, I can bring out cosine t dt. So I know the antiderivative of cosine is sine. And I'm going from 0 to pi over 2. So this would be a no calculator problem, unlike the ones that we were doing earlier. So this is 6 times the sine of pi over 2 minus the sine of 0. So that is 6 times. The sine of pi over 2 is 1. The sine of 0 is 0. So I'm getting 6. So this area is 6, guys, which means this area is 6, and that area, this area is 6. So if I actually wanted to go from 0 to 3 pi over 2, do you see it would be 6 minus 6 minus 6? So my displacement is negative 6. So this particle is going to wind up 6 units to the left of its initial position. That's what the displacement stands for. Now the total distance traveled would be, if I went from 0 to 3 pi over 2 of 6 cosine t in absolute value. But do you see that that's going to be 3 times 6? Because it's going to be 6 plus 6 plus 6, since I've broken it into 3 little parts. So the particle travels a total of 18 units as it's going from 0 to 3 pi over 2 in time, but it's actually going to wind up only 6 units to the left of its starting point, is what we've got so far. So find the position of the particle at 3 pi over 2. Now I want to use the construct that new position equals original position, or initial position, plus accumulated position. I'm going to start abbreviating because I want you to get used to how you can apply this idea. Well, its new position would be its position on the x-axis at time 3 pi over 2. Its initial position is where it was at the beginning when time was 0. Its accumulated position is the integral, and accumulated position is the same thing as net. It's the same thing as displacement. Okay, so x of 0 I knew was 4. All right, I've already figured out from 0 to 3 pi over 2 of 6 cosine t is negative 6. So guys, it's telling you that it winds up at negative 2 on the coordinate negative 2 on the x-axis. So at what time is the displacement 0? So does it make sense that you're looking for the time where, as far as it's moved to the right, it moves back that far to the left, so it winds up back on the origin? Well, do you all realize that would be at time pi? Because the area here is going to be equal to the area there, and they're going to cancel each other out. So when is the displacement 0? Let me say at t equals pi. Okay, so that's when the amount that it's traveled to the right, which is represented by positive area under the curve, equals the amount that it travels back to the left, which is represented by negative area under the curve. So another particle motion problem. A particle moves, and this is number 2 from the AP exam. So guys, that means it's a calculator problem. All right, so a particle moves along the x-axis with a velocity given by blah, blah, blah. The particle is at position x equals negative 5 at time t equals 0. So we're going to do a very similar problem. I'm just going to cut out some of the extra stuff. So we're cutting to the chase, so you'll see what they look like on the exam. So find the acceleration of the particle at time 3. You all may be thinking, acceleration, that's not what we're supposed to be doing. No, part A is a review question because I want to keep kind of showing you AP-like questions, and there will be a mixture of these on our quiz, okay? So find the acceleration at time 3, okay? That's what I want on part A. Well, do you know that acceleration is the derivative of velocity? So you want the derivative at time 3. Guys, it's a calculator problem. You don't need to do anything else, okay? Once you tell them that you're doing v prime of 3, that you've indicated to them what you're thinking, that you understand how the problem connects to a calculus structure that you have in place, then just go to the calculator. So I'm writing the equation down so I can see it to put in my calculator. I'm writing on my whiteboard. If you all were here, you would see all this. Otherwise, I'm spending my Saturday teaching to an empty classroom. So let me see. I'm going to plug in the calculator, and I need to say y equals, and I clear out what's already there. So I've got 10. I'm going to do this in parentheses. So 10 and sine of 0.4t squared and I need to close up the 0.4t squared and the 10 sine of that all together divided by, and then I need to say parentheses, t squared minus t plus 3. I just realized this is not Saturday, this is Good Friday. So I'm spending Good Friday here teaching you with you out you being here. All right, so I'm going to go to my home screen. And remember, I wanted to do the derivative of this function at 3. So I'm going to go to my math menu. Choice 8 in deriv. We've not done that for a while. So d dx of what I put in y1 at x equals 3. So negative 2.1182. So negative 2.1182. Does it say that you need to give units? No. Okay. So I wanted to make sure that we put the units on there, but I don't even think we've got units to work with, period. All right. So we've got the first one done. Now, find the position of the particle at t equals 3. So the second problem is when we have to get into saying, oh, okay, we just did this. New position equals initial position plus accumulation. So I always say plus accumulated position. And I always set it up just like that. So its new position would be x and it says at time 3. So where is it at time 3? Its initial position would be where it is at time 0. And its accumulated position would be from 0 to 3. And you're going to integrate rate to get amount. So integrate rate would be velocity to get a displacement. So now I've set it up. Do we know where it is at time 0? Yes, we do. The particle is at x equals negative 5 at time 0. So I'm going to say negative 5 plus. Now, I've established that I'm going to do that definite integral. I don't need to show any more work. All I'm going to do is fill in the blanks. Okay? So the first thing I need to do is integrate from 0 to 3 on my calculator. So math, because I've already got y sub 1 in there, thank goodness. This is why I'm suggesting you put it in at the beginning, because you usually on the AP exam will have to work with the same function 2 to 3 times. If it's in y1 from the get-go, you only have to be super duper careful entering it once, and that ultimately saves time but also helps make you more accurate if you're careful one time and you don't make keystroke errors. So I'm getting on that 3.2398. And then, of course, I need to say negative 5 plus that. So minus 5. So negative 1.7602. So you're saying after 3 seconds or whatever have passed, it's at negative 1.7602 on the x-axis. So there you go. And that is it. You've seen a lot. And tomorrow we won't have to do any more new lesson. We'll just practice, because I know that you probably just feel like you've been hammered with applications. Hopefully they're not quite as bad as you thought they might be. All right, I'll see you in my Zoom classroom so I can help you with tons of questions. Good luck, guys.